Hello everyone, my name is Neha. I am a student of BSc Chemistry Honours 4th semester and I am here for making a presentation video on nitro compounds. So let's get started. As we all know that nitro compounds are those compounds having a functional group and no two attached with them. So now we will begin from the preparation of nitroalkanes. We can prepare nitroalkanes from alkanes by the following method. This method is also known as vapor phase nitration as it takes place in the vapor phase at 673 Kelvin in presence of fuming HNO3. Suppose for example we take an alkane like methane which reacts with HNO3, fuming HNO3 at 673 Kelvin temperature to give nitroalkane which is nitromethane CH3NO2 plus water. The second method to prepare nitroalkanes is from alkyl halides. Alkyl halides react with silver nitrate in the presence of alcohol, and by heating this mixture we get the corresponding nitroalkane along with alkyl nitrite, which is the side product or the minor product formed along with the main alkyl nitroalkane. Also, we can prepare nitroalkanes using tertiary alkyl amines, for example, taking a tertiary alkyl amine and treating it with KMNO4, we can get the corresponding nitroalkane which is as follows. So this was the another method by which we can prepare nitroalkanes. Now moving ahead, we'll start with the preparation of nitroarenes. The first method to prepare the nitroarenes is by treating them with nitrating mixture. Or we can say nitrating agent, which is concentrated HNO3 plus concentrated H2SO4. The reaction is as follows. Suppose we take an aromatic compound such as benzene, treating it with HNO3, fuming HNO3, concentrated HNO3. In the presence of concentrated H2SO4, we will get our required nitroarene. Here in this particular case, the required nitroarene is nitrobenzene plus water as side product. The mechanism of this reaction is as follows. First of all, the first step of the mechanism is to generate the electrophile. That is, from HN, we can represent the HNO2 as follows: plus H2SO4. So here the required electrophile is nitronium ion plus H3O positive plus HSO4 negative. Now this electrophile reacts with the benzene in step 2, which is the rate determining step. Which takes place as follows. Now the benzene ring attacks the electrophile in such a way that it forms a carbocation Now the HSO4 negative, which was formed in earlier step, acts as a nucleophile on this PC and attack on this hydrogen atom, and the reaction proceeds in the following way. And we get our desired product, that is nitrobenzene. Now we will study about the reactions of nitroalkanes in which Ac-nitro derivatives act as nucleophiles. So let's proceed. The first reaction is aldol condensation. In this, let us take the example of nitromethane. In presence of OH negative nucleophile, we can say that water gets eliminated and we get CH2 double bond and positive double bond. The structure as follows. In this reaction, this is our required nucleophile which will attack the given aldehyde. Like for example, this nucleophile can be written as Now we will proceed further. Let us take an example of aldehyde, that is acetaldehyde CH3CHO, and the earlier formed nucleophile. Now this nucleophile attacks on the aldehyde molecule in the following way. And both the molecules form an adduct kind of molecule which is as follows. Now we can further proceed the reaction as this O negative attacks on the H positive of water molecule and OH negative ion eliminates from the mixture and we get the following compound. We can further split this CH2 as CH and H written. Now from this compound, a molecule of water gets eliminated in the following way. And we get the following compound, which is namely 1-nitropropene 1-ene. The structure of this compound is as follows. The driving force for this dehydration is the gain in stability due to conjugation of ethylenic double bond with the double bond of the nitro group. The next reaction, in which acetonitro derivative acts as nucleophile, is Michael reaction. In this reaction, again we start from by taking a nitroalkane molecule like RCH2 NO2 and in basic medium this slow step results in the formation of SC nitrofoam, that is the required nucleophile of this particular reaction, RCH double bond NO2. Now here alpha beta unsaturated carbonyl compound will act as an electrophile and will give the addition product of both the molecules respectively. So the reaction will proceed as follows: R dash SCH double bond CH CO OC2H5. So this molecule will act as an electrophile. Now here the attack takes place from the nucleophile as follows. So we get the following addition product, which is CH2 CO C2H5. So this is the final product of this named reaction. Now the next reaction is halogenation. SC nitroforms generated from primary and secondary nitroalkanes in presence of alkali react with electrophiles such as chlorine, bromine in presence of alkali like NaOH to form halonitroalkanes. During this reaction, alpha hydrogen atoms have the main role. That's why tertiary nitroalkanes do not give this or undergo this halogenation because they lack the presence of alpha hydrogens. So the reaction for this particular situation is as follows. Let us take an example of CH3NO2 in the case of primary nitroalkane, and let it be treated with chlorine gas in the presence of NaOH. So here we will observe that all the 3 alpha hydrogen atoms of the 1 degree nitroalkane are replaced by the chlorine atom, and thus we get the final product as CCl3 NO2 plus NaCl and water as side products. In the similar way, 2 degree nitroalkanes undergo the reaction. Now we will study about the reactions in which Ac-nitro-form act as electrophiles. So in this category, the most important reaction, which is referred as Neff-carbonyl synthesis. During these reactions, the Ac-nitro-form acts as the electrophile and water as the nucleophile. So we have taken a sodium salt of nitrolic acid to start the reaction, and we can represent it in a way RCH double bond NO, O negative, Na positive. In the presence of 50% of H2SO4, this PC gets converted into a electrophile, or we can simply say that we can write this structure as like this, and this acts as an electrophile, and here water molecule will act as an nucleophile. So this nucleophile attacks on the carbon atom of this electrophile, and the transfer of electrons takes place in the following way. Now in this reaction, proton transfer takes place in the next step, and we get the compound as RCH, OH, N positive H, and 2 OH groups attached with this nitrogen. Now this H atom gets released from this compound, and we get RCHO, that is an aldehyde. Similarly, if we take 2 degree nitroalkanes, then on treatment with 50% of H2SO4, they give ketones. In the similar way in which we preceded this reaction. Now the next reaction is hydrolysis. Primary nitroalkanes, when treated with boiling HCl or 85% H2SO4, undergo hydrolysis to form a carboxylic acid and the corresponding salt of the hydroxylamine. The reaction can be written as RCH2OH NO2. RCH2NO2, 1 degree nitroalkane reacted with HCl H2O and will heat the mixture. The product formed is RCONHOH. Now again treating it with HCl in presence of water, we get the corresponding carboxylic acid, which is RCOOH plus hydroxylamine hydrochloride as a side product. This reaction is used for the manufacture of hydroxylamine. In contrast, if we take secondary nitroalkanes for the hydrolysis process with boiling HCl, then they give a ketone and nitrous oxide. The reaction can be written as R2CHNO2 treated with boiling HCl gives out R2CO. We can write ketone in this form also, plus N2O, that is nitrous oxide, and water as side products. Now the next reaction is the action with HNO2, that is nitrous acid. So if we take a 1 degree nitroalkane, let us say RCH2NO2, and treat it with HONO, that is HNO2 nitrous acid, so we get nitrolic acid, that is RCNOH NO2 plus water. This is a compound which gives blood red coloration and dissolves in NaOH. Now this was the case of 1 degree nitroalkane. If we take 2 degree nitroalkane, that is R2CHNO2, and treat it with HNO2, then we get this pseudonitrol and water as a side product. This pseudonitrol compound gives blue coloration, and also this does not dissolve in NaOH, or we can say alkali. Now the next reaction is Manish reaction. In this, 1 degree and 2 degree nitroalkanes undergo this particular reaction. 1 degree and 2 degree nitroalkanes are treated with HCHO plus any 2 degree amine. We can take an example of CH3 whole twice NH, and we get an addition product as a result. We can write the following reaction as, in the case of primary nitroalkane, we can write RCH2NO2 plus HCHO plus CH3 whole twice NH in acidic medium gives us RCHNO2, CH2 and CH3 whole twice plus water as side product. Now we will study a special important nitro compound, which is picric acid, whose formula is 2,4,6 trinitrophenol. Its structure can be represented as First of all, we will start with the preparation of picric acid. The first method is from phenols. If we treat phenol with concentrated H2SO4, we get the following product, that is phenol 2,4-disulfonic acid. Which on treatment with concentrated HNO3 plus concentrated H2SO4 gives us picric acid. The second method is from chlorobenzene. We can treat chlorobenzene with HNO3 in presence of H2SO4, that is, we will precede nitration and the compound formed is 2,4-dinitrochlorobenzene. Further, we will treat it with aqueous Na2. Now we will treat this compound with HNO3 and H2SO4 and get the final product, that is picric acid. If we talk about the physical properties of picric acid, then it is a yellow crystalline solid which is sparingly soluble in water, but it is soluble in alcohol and ether. If we talk about the name, then the name of picric acid is derived from a Greek word, that is pikros, which means bitter. And from here we get to know about one more property of picric acid, that is, it is bitter in taste. Or also, if we talk about the uses of picric acid, then it is used as an explosive. Also, it is used as a direct yellow dye for wool and silk, and in medicine as an antiseptic for burns. It is also used as a laboratory reagent for characterization and purification of polynuclear aromatic hydrocarbons, amines and phenols. Thank you for watching my video.